Hey, it's Mr. Barr, and this is Linear Systems in Real Life. So let's get going here with some notes. Our learning goal, I can use linear systems to solve real life problems. Why? Line equations will help me understand the world around me and make predictions. Why are we doing all this math? Because systems, more than two things acting together, exist in the real world. And today you're going to look at some simplified examples of systems in the real world. So let's get going with our notes here. And start with your name. And our title is Systems, Linear Systems in Real Life. And I've got one big piece of advice for you. So here's our first type of problem is Drew currently has $20 and is saving $5 per week. Kyle has nothing and is saving $10 per week. When will they match up? When will they have the same amount? And what's your idea? And my idea is we're going to make a table. So this first one, Drew has $20 and is saving $5 per week. Kyle has nothing and is saving $10 per week. And we're going to try to figure out how many weeks it's going to be until they have the same amount of money. So here's our table. We're going to have week, Drew, Kyle. And I think the most confusing part of this for most people is that we actually start at week 0. Before we even begin, Drew has some money. Drew has $20 at week 0. In his pocket, before the game even starts, Drew has $20. And Kyle has 0. Then at week 1, Drew has $25. And Kyle has 10. And now we're just going to follow the pattern. At week 2, Drew has $30 and Kyle has 20. Right? It's going up by 5, 20, 25, 30, 35, 40, 0, 10, 20, 30, 40. And where's that occurring? It's occurring at week 4. At week 4, they have the same amount of money. The big idea is to remember to start at 0. The biggest error I see is people starting at 1 and going 2, 3, 4. No, start at 0 because there's an initial starting point value there where the initial amount of money that they have. Okay, so now let's do some problems on the computer. I think that's probably it for the notes. Oh, Okay, this lesson is it's like a 2-in-1 lesson. Two lines with the exact same slope and the same y-intercept will intersect at exactly 1 point. Okay? Come back to your notes. For the line problems, draw lines. So this one, two lines with the same slope and the same y-intercept will intersect at exactly 1 point. Two lines with the same slope and the same y-intercept. Okay, there's a line and it has a slope and a y-intercept. Here's another line with the same slope and the same y-intercept. Do those intersect at exactly 1 point? No, they're going to intersect at infinite points, right? So is this true sometimes? Do they intersect at 1 point? Sometimes? No. All the time? No. Never? Yes, never. They will never intersect at exactly 1 point. All right, let's do this one. Okay. So Rachel went to a carnival that cost $4 to get in, so she spends $4 before anything even happens. Robert goes to a carnival that's free. Rachel, each game costs $2. So she plays one game, she's up to 6, 8, 10, 12, 14. Robert, everything is $3. 3, 6, 9, 12. Where does it meet? It meets at 4. Two lines with the same y-intercept will intersect at exactly 1 point. Okay, told you what to do. You need to draw pictures for this. Boom, graphic. Two lines with the same y-intercept there's a line. There's a line. They have the same y-intercept, don't they? Ooh, will intersect at exactly 1 point? Well, initially it feels like, yeah, 1 point. But what about this? Ready? Here's another line. Remember coinciding lines? Oh, look how this red line. Notice how this line, and the green line are coinciding. So 1 point, sometimes I can make it do 1 point, but other times it's going to be infinite points. So it's true sometimes. Sometimes I can make it do 1 point, but sometimes I can make it do infinite points. All right, cell phone A is free, but you pay $2 a day. Cell phone B is $28 and you pay $1 a day. So 0, 2, 4, 6. This guy would be 28, 29, 30, 31. So I'd have to just continue this table out, or I could kind of jump ahead a little bit. Let's try this. Let's go to 10 days. 10 days, this would be, how much would this be? This would be $20. After 10 days, this would be $38. Haven't met. Let's go out to 20 days. At 20 days, this would be $40. And this one would be $48. Still haven't met. We're getting closer. Let's try 30 days. At 30 days, this would be $60. And this one would be 28 plus 30, 58. Ooh, you know what? They just crossed somewhere. They're crossing right up in here. Let's try 29 days. At 29 days, this would be 58. And this one, I would just go back one day, would be 57. Let's try 28 days. At 28 days, this would be 56. And this would be 56. So it's going to happen at 28 days. So you notice I didn't actually just go out to 28. I kind of jumped around and figured it out. Two lines with different slopes will intersect at exactly one point. And this is true for all cases. If I have two lines with different slopes, right? Different slope, one point right there. There's no way, the only way to get infinite would be to have the same slope. As soon as the slopes are different, there's going to be one point where they intersect. Seth has $10 and is earning $10 a week, so he starts with $100. Caden has $200 and is spending $10 a week. So this is going to be $110, $120, $130, $140, $150, $160, $170. He's spending $10 a week. This is going to be $190, $180, $170, $160, $150. Oh, right there. It occurred right here. 5 weeks, they have the same amount of money. 5 weeks, same amount of money. Two lines with the same slope will never intersect. So there are two things that could happen here. Two lines with the same slope. Two lines with the same slope can either be parallel, or two lines with the same slope can be coinciding. Will never intersect. Sometimes they never do, like right here, but sometimes they do. Sometimes they don't, sometimes they do. So this is true for some cases. Sometimes they cross, sometimes they don't. Morgan is going to join a gym that costs $45. Ooh, my line is way too big. And Skylar's going to join a gym that's free to join. And this one's going to be $30 a month, so 45 plus 30, 40, 50, 60, 75. Plus 30, 105. Plus 30, 135. Plus 30, 165. Plus 30, 195. Skylar, 35, 70, 105, 140, 50, 60, 75, 175, 110, 145. What? This is 210. 245. Let's add 30 to this, takes me to 125. 30 to this takes me to 225. 30 to this takes me to 255. They just crossed somewhere. I messed something up, didn't I? I messed it up. I messed it up. Let me turn on my light and get a calculator. One of those things I messed it up, didn't I? 45 and 30 a month. So 45 plus 30, 75 plus 30, 105 plus 30, 135 plus 30, 165 plus 30, 195 plus 30, 225 plus 30, 255. That one looks good. Let's try the other one. 70, 35 plus, 35 plus 35, 70 plus 35, 105 plus 35, 140 plus 35, 175 plus 35, 210 plus 35, 245. No, I guess I'm getting close. It must be like one more iteration out here. Add 30 to this one, 50, 60, 70, 85, 285. And add 35 to this one, 45, 55, 65, 75, 80. It's right there. No, 80. This is 280. It's going to happen right here, isn't it? Adding 30 to this one takes me to 3, 8, 9, 10, 11, 315. It's right there. So it occurred there at 9 weeks. And occurred at 9 weeks. See it right there. 9 weeks. All right, hey, that's it. Thanks for watching. Have a good day.